Okay, so we have 2 lessons left in this chapter, 6-6 and 6-7. 6-6, it kind of switches gears at the end of this chapter. It focuses on functions, and we're going to do some stuff with some functions now. And we're going to do function operations. Okay? So operations, they can be simple or they can be kind of complex. So we're going to start with some easier stuff. We're going to do some operations, your basic operations. Okay. Basic operations are adding, subtracting, multiplying, and dividing. So here we go. We're going to take functions and we're going to add them. So, for example, if you were to have f plus g, let's say f is a function and g is a function, and they're both functions of x, and that's going to look a little tricky, but it's actually pretty easy. All you do is you take f of x, that function, and add it to g of x. Okay? So, here's an example of that. Example number 1. Let's say that f of x is 3x plus 8, and g of x is 2x minus 12. And let's say that we want to find f plus g of x. Now, when you look at that, it just looks kind of weird. Like, how am I going to add the f and the g, and it's of x? But all it is to take the function f of x, right here, it says f of x, which is 3x plus 8, and add that to function g of x, which is 2x minus 12. Okay? And so all you're going to do is just combine your like terms. 3x plus 2x is 5x. 8 minus 12 is negative 4, and that would be your answer. That's it. So you're given 2 functions. They ask you to add them up. You just add their like terms. All right. We can also subtract functions. And to subtract functions, that would be f minus g of x, which I'm sure you're thinking is the same thing as to take function f of x minus function g of x. Okay? So let's just use those same f of x and g of x up there. Now, subtraction is actually a little tricky. Okay? People can add really easily. When you start subtracting, that's hard, especially when you subtract like negatives and stuff. People get a little confused. So if I'm going to take f of x, which is 3x plus 8, we'll just stay with those same f of x and g of x. And I want to subtract function g of x. Here's where people will make a mistake. They'll forget to subtract all of it, right? You need to distribute the minus sign to all the terms in g of x, okay? So I'd like to tell you what people do to get this one wrong so you won't be those people. All right, so what we have is we have 3x plus 8 minus 2x plus 12. Okay, so distribute the minus, and there could be 3 terms or 4 terms, whatever. Everybody's going to get a minus onto it. So 3x minus 2x is x. Oh, fun. 8 plus 12 is 20. Okay, and that would be those 2 functions, f of x minus g of x. All right, so after you learned how to add and subtract when you were a child, then you finally learned to multiply. So to multiply 2 functions looks like this. F times g of x.
Is that foiling?
It is. If it's 2 binomials, you'll have to FOIL. Are you tired of foiling? Oh, okay. But are you, though? I wonder how many times I've foiled in my life. A lot. Too many? Not enough. All right, here we go. So 3x plus 8, we'll stick with that f of x. Uh-huh. Yeah. First outside, inside last. And then 2x minus 12. So we'll stick with f of x and g of x from our original problem. And you got to FOIL that out. You're so good at foiling by now, though. Here we go. 3x times 2x is 6x squared. Outside is negative 36x. Inside is 16x. Would you wish your calculator would do this for you? I know. You paid enough for it. And the last would be 8 times 12. What's 8 times 12? 96. Good. Okay, and don't forget to combine. Usually those middle terms add up. So 6x squared minus 20x minus 96. All right, and finally the last one, divide. To divide these two functions, it's f over g of x, which is simply just to take function f of x and divide it by g of x. Now, a lot of times there's nothing to do, except you do need to tell me what the domain is on this. Now, let's talk about domain real quick. The domain of a function are the what values? The x values. Good. Domain of the function are the x values. Okay? Lots of times we've had parabolas and the domain was all real numbers. In this case, we're going to get a domain that is not everything that we're allowed. Okay? So let me show you what that means. So let's divide those two functions that I gave you. So we'll do, the division would be 3x plus 8 divided by 2x minus 12. Now, you don't need to simplify that. You don't have to divide it into it or anything. That's actually a fine answer. But I need to tell you the domain of this. And the domain is going to be all real numbers except for one number. There's one number that I'm not allowed to plug in. Do you know what it is? Nope. But you're on the right track with 0. You're on the right track. Nope, it's positive. 1? 1's fine.
Wait, you're trying to plug in?
You're trying to figure out what number you're not allowed to plug in for x.
3, 2.
Nope, haven't heard it yet. Okay.
12, 4, 6.
6! You were going to get there, weren't you? Okay. The domain, I'll tell you right now. The domain is all real numbers except for 6.
Oh, I think I see it.
You do?
Yeah.
Plug 6 in. Well, you get 18 plus 8. But what happens on the bottom? What do you get?
0.
You get 0. Are you allowed to have a number over 0? No. We call that undefined.
How would you know that? Like, not what number to plug in?
Okay, so how do you know that, right? Well, first of all, let's talk about how you can't have 0 in the denominator. Even your calculator knows that. If you did 1 divided by 0, your calculator would say, divide by 0, you can't do it. Have you ever asked Siri? There was like this thing going around if you ask her, what's 0 divided by 0? Yeah. It's cute. Okay, you can do it on your own time. All right, but you cannot have 0 in the denominator. And another way to look at that is by using food, right? We love food. If you've decided that you're on a diet and your friends order a pizza and there are 8 slices and you've decided to take 0 out of 8 slices, that's fine, right? But you cannot take 1 slice out of a pizza that never arrived, okay? It's not allowed. So how did we get 6? How did I get 6? Well, what you do is this. You take the denominator and you say, this cannot equal 0. And you solve that. Add 12 to the other side. Divide by 2, x cannot be 6. Okay? You figure out whatever's going to make the denominator 0, and you're not allowed to have that. So your answer would be this entire thing.
What?
Your answer would be 3x plus 8 over 2x minus 12, but x cannot be 6. So let's do one more of those, just so you know. Okay? Let's say f of x is x plus 4, and g of x is 3x minus 9. Okay? If I ask you to do f divided by g of x and tell me the domain, I need to know the domain.
X plus 4 3x minus 9.
Okay, that's like the easy part, right? Everyone can do that. You just take f of x, which is x plus 4, and just write it over 3x minus 9. Don't start canceling things out. That would be wrong. Just leave it, okay? But the domain is everything I want except for whatever makes the denominator 0. What would make the denominator 0 here?
3.
3. Good. Did you just do a little trial and error in your head?
No, because
You can plug that or set it equal to 0 and find out what would make the denominator 0. Add 9, divide by 3, so x would be 3.
isn't this just pretty much like what number is gonna like add up or multiply into 9?
Yeah, pretty much. That's what I was thinking.
Yeah, but there's other tricky ones. Like if you had something like, let's say you had 2x over x squared.
Do you always do the denominator?
Yes. X squared minus 25. What would the domain of that one be?
5.
Or negative 5. See that squared right there? So this would be, I know, all reals except for plus and minus 5. Tricky. Very tricky. All right, let's move on.
What?
That's good. Okay. The squared part? Yeah. If you set the bottom, the denominator equal to 0, and you solve that, when you move that 25 over, you have to take the plus and minus square root of both sides, remember? And you get plus or minus 5. Good job, Cam. You said negative 5. Okay. Now, part B and C are going to go together. So we know how to add, subtract, multiply, divide functions. We're good. But now we're going to do something called composition. Sounds tough, huh? Composition of functions. And this is the new part today. This is new to you. Composition of functions is like, what's that movie where it's a dream inside of a dream?
Yeah.
Inception? Yes. That's what this is like. We're going to have functions inside of functions. Okay?
That's already confusing by itself.
I know, right? Okay. So let me show you what it looks like. If you have F, and then you write this little circle. Here's a new symbol for you today. F of G
Fear of God.
Don't tell me
of
that's
X. No.
Okay.
It's a little circle. It's a circle. Okay, looks like fog. F of G of X means this. You're going to take F, and you're going to put function G of X into function F. Yeah. No, it's not too bad.
That's just multiplying.
It's not multiplying. Nope, it's not distributing. Now, if you did the other way, G of F of X, okay, everything's in order still. It's F of G of X, it's still over here, F of G of X. This is G of F of X, it would be G of F of X. They're very different from one another. They're hardly ever equal to each other. They only are if your functions are inverses of one another. We're going to learn that on the block day. So this is what you do for these problems is if you are doing, say, this one right here, okay, whenever you have parentheses, you always work from the inside out. You would find out what G is, G of your number, and then you take your answer and you'll plug it in for F. Okay? Very confusing using just words, so let's do an example. Here we go. Number, what are we on? Like 2? 4? 5? 3? Okay. All right, so here we go. Let's say that F of X is X minus 2, and G of X is X squared. Okay, so F of X is a line and G of X is a parabola. And what I want to do is I want to find out what F of G of 4 is. Okay, so let me show you. There's one answer to these. Some people think there's 2 answers, but there's not. There's 2 steps to get to your one answer. So this is what you want to do first. You want to evaluate what G of 4 is. Okay? So G of 4 is to plug 4 into function G up here. So I would get 4 squared, which is 16. Now I'm not done. Now I need to evaluate F of 16. See? F of 16 would be now to take 16 and plug it into function F. 16 minus 2, your answer is 14.
So did you multiply 4 twice?
No. Well, yeah, because that function G is telling me to square it. So this is what's happening. Let me draw this for you as like a little function rule. So here's your, oops, I don't like that part. Do you get it? Okay. This, let's say this is g of x. Okay, this is a function machine. And then let's say that f of x is over here. It's a different machine. It's going to shoot out this way or something. I don't know. Okay. So what's happening here is 4, the number 4, is going into the function g. And it gets mixed around. Boop, 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 boop. Function g is a squaring function. So what happens is output is 16. The function g of x is a squaring function. It squares whatever you plug into it. But then 16 is not done. 16 is going to go into this function, which is f of x. And then when it comes out of there, it goes into the f of x function, which tells you to take any number and subtract 2 from it, and you get 14 at the end. You like the pictures? It's good, huh? So a number goes into one function, comes out as something, that number then goes into the other function, and then you get one answer at the very end. Your whole thing is this entire thing. Not part of it, but the entire thing. Isn't that fun? Let's do some more. Letter B. You're going to, someone just say I'm going to drop?
No, I'm trying to drop.
Oh, I thought you said I'm going to drop this class. I'm done. Okay, let's do the other way now. Let's do g of f of, let's do 5. G of f of 5. Now, a lot of people don't like it written with the circle. Okay, they prefer to write it with parentheses. I do, personally. So what you can do is, oh, don't give up. Don't give up. I know, you're on your iPad. Don't do it. Listen to this. No. All right, G of f of 5. People like it written like this better. Okay? G of f of 5. Do you see how I didn't change the order at all? G of f of 5, G of f of 5. But people like it written like that better. All right, let's do it. And you can do these in your head when you start to get pretty good at them. So 5 is going into which of my two functions first? 5 is going into function f. Do you see that? And what is f of 5? Evaluate f of 5. What do you get? 3. Then take 3 and plug it into function g. 9. And that's your answer.
Explain how you got 3 from 5.
Oh, because you flipped it.
Okay, do you see these up here?
Yes.
These are the functions that we're using. So I went and I plugged in to find out what f of 5 was.
Oh, so it's just 5
So f of 5 is 5 minus 2, which is 3. But I'm not done. That's just this part inside here. Then once I get that answer, I go up here to function g and plug it in, and my answer to the entire thing is 9. You want to try one now?
Yeah.
Good.
$.
Okay, try this one. G of f, ooh, I'm going to give you a hard one, of negative 3. G of f of negative 3. You try this one. It's okay if you're wrong. We'll fix it.
Thank you.
Yeah, we're still using those same functions from up above. So f of x was the function that took x minus 2, and g of x is the squaring function, x squared. All right, try it. These aren't that bad. They're bad at first because it's like, whoa, I've never seen anything like that before. But once you get used to it, it's okay.
Oh, I think I got it.
Okay, here we go. Let's do it. First, evaluate the inner function. The inner function, is f of negative 3. So negative 3 minus 2 is negative 5. Now be careful. Negative 5 is going in now to function g. And when you take negative 5 into function g and you square it, you get positive 25. Who got that? Oh, good. Like 10 people got it. Even Cam did. So that's very exciting because he wasn't paying attention. All right. Let's do one more of these, and then we'll move on to a different function. Yeah? No, you don't have to show work. You can do these in your head. Perfect. Oh, yeah, there's part C. It's hard. Okay. How about g of 3? G of 3. g of 3. Gog.
Are we just putting it into the thingy?
Yeah. Now, remember, a lot of people don't like it written with that circle. So you can rewrite it like this, and that might make a little bit more sense to you to see what you're doing. You're plugging in 3 into function g. You're going to get an output, and then you're plugging it back into function g. It's almost like you're washing your clothes twice, but then you're done. Okay, so 3 goes into function g, and g squares it to give you what, 9? 9 goes back into function g, and it squares that, and you get?
7. Wait, hold on. Okay, I did the first because I
right.
knew I was laugh. Go ahead.
No, it's okay. You did f. You did f of g of 3.
I did F. That's
It's
fine.
g of 3, and you get 81. And you did it in your head, and that's fine. You don't have to show work on those. I don't mind you not showing work, okay? They're going to be worth 1 point on the quiz. They're right or wrong. You're done. G of 3. So 3 goes into function g, which is right here, and it gets squared. So g of 3 goes in, you get 9. Then I have to go and plug 9 into function g, and 9 squared is 81. You do it twice. All right, so let's move on to part C now. Now, this is the hardest part, because now we're not going to have numbers. We're going to have variables. Okay? No more numbers. So, here we go. Number whatever on 3 or 4 or whatever. Okay. Let's say that f of x is the function 2x plus 1. And g of x is 3x. All right. So there's our 2 functions we're given. And we're going to do f of g of x. Okay? Not a number. Not a number, but just a variable. And our answer is going to be in terms of x now. It's not going to be a number answer. Okay? So let's talk about what this means. Start with the inside. See, the inside is g of x. Well, what does g of x equal? It equals 3x. So this is telling me to take whatever g of x is, which is 3x, and plug it into function f. So what I'm going to do is I'm going to, if I were to tell you what's f of 5, you would take the x out and you would put 5 in, right? What we're going to do now is we're going to take that x out and we're going to put in 3x for it. Now the thing that people will accidentally do is they'll multiply their x's and get x squared, but you're not. You're taking this x out, replacing it with 3x. That's what you're doing when you evaluate a function. Right? If I ask you again, what is f of 5? You would go 2 times 5 plus 1. So I want you to do f of 3x. You're going to do 2 times 3x plus 1. And what would your answer be? 6x plus 1. Okay? It's harder though because there's not numbers. It's the entire grouping thing goes in. All right, let's go the other way now. Well, no, I just want you to be able to do this. This is the hardest part of today. This is the last thing that you're learning. No. A lot of people don't like this part. All right, we're going to go the other way now. We're going to now take function f of x and plug it into g.
So is this distributing pretty much?
It is. Yep, that's exactly what you're going to do. Okay, so here we go. We're going to take f of x, which is 2x plus 1. So this is f of x, and we're going to plug that in to function g. So what we do here is we do 3. Instead of that x right here, we're going to plug in 2x plus 1. Okay, yes, and distribute 6x plus 3. That would be your answer. Is that hard? Not too bad? All right, we'll do one more. And then we'll call it a day.
Promise?
Promise, yeah. Okay, this one's a tough one, though. Are you ready for it?
Oh boy.
Hardest one of them all. F of x equals x squared plus 1. And g of x is x plus 3. Okay, so let's do g of f of x first, because that's actually the easier one. We'll do g of f of x first. Okay, I'll let you get caught up a minute. No. See, that's a mistake that people will make. They'll start multiplying the x's to each other, but you're not. You're replacing them. So if you look at this, I have f of x, which is x squared plus 1, is going in place of this x right here. This x is being tossed out. Bye-bye, gone. And x squared plus 1 is being put into it. Just like if I were to say, like, what's g of 10? You wouldn't say it's 10x plus 3. You take the x out, you put the 10 in. So you take the x out, and you get x squared plus 1 plus 3, yep, which is x squared plus 4. Perfect. Okay? So yeah, don't multiply them together. You're replacing them. Substitution. All right, let's try the other way. The other way is a little harder. This is the last problem of the day. No. Go back. F of g of x. The other way. F of g of x. Okay. So we're going to take function g of x, which is x plus 3. Yes. And we're going to plug it into function f. That x is gone. Not quite. That x is gone, and I'm left with x plus 3 squared plus 1. Okay? Do you see how function f is x squared plus 1? What I've done is I've taken out this x, and I replaced it with x plus 3. Yeah. So this x is gone. The x plus 3 comes in. And so you have to FOIL. So we're going to do x plus 3 times itself, unless you know the shortcut on that. Shortcut's kind of fun. You want to know the shortcut on a binomial squared?
Sure.
Okay, you can FOIL it out. That's fine. But if you want to do x plus 3 squared, what you do is you square the first term, you square the last term, and then there's a middle term. The middle term is just all these things multiplied together. X times 3 times 2. 6x. Pretty cool, huh? You don't like it? If not, FOIL it out. X squared plus 3x plus 9. And then there's still that plus 1. So you get x squared plus 6x plus 10 as your final answer. Because it was x squared plus 1. There was a 1 there. Yeah, you have to add that 1 at the end. All right.